All right, let's talk about vertical motion. And of course, the most fun part of math, which is modeling things, because after all, that's why we do math. Um, so, a couple things we need to know. First of all, that position in a gravitational field is 1/2 the gravitational constant times the amount of elapsed time squared. On Earth's gravitational and this is in free fall. Um, Earth's gravitational constant is 32 feet per second squared. And then, of course, it's also 9.8 meters per second squared. And if you do any physics or certain types of engineering, you will become intimately familiar with these. So let's model some vertical motion very quickly. This is example 4 in the book. I'm going to pause for just and turn a light on because it is starting to get dark outside. So here's what we got. We launch a rock into the air. Why? Because we can. Heavy rock, there it is. Straight into the air with a launch velocity of 160 feet per second. The position of the rock can be modeled by 160 times t minus 16t squared. And you'll notice that this is your initial velocity. So basically what you've got is how far up have I gone based on the initial velocity minus, and then we've got gravity dragging us back down again. So we want to know the max height. This is our first question. And of course, what do we know about the trajectory of a rock? Well, the max height is going to be when v is equal to 0. Excuse me, v is equal to 0, which means that s prime is equal to 0. So let's find the first derivative, and we know from our rules of derivatives that that's 160 minus, carry the 16 out, bring the 2 down, that's 32, reduce the power by 1. And we want to set that equal to 0, and we get that a time of 160 30 seconds is when we'll, and that looks like 5 seconds. I'm doing a little quick mental math. So at 5 seconds, we will reach the maximum height. The velocity of the rock 256 feet above the ground. So we want to find v of t when s of t equals 256. Well, obviously the easy answer is, well, then we need to find t. So we'll set s of t equal to 256, 160t minus 16t squared. This is a quadratic, so I will quickly solve the quadratic. Of course, I've already done it in my notes, and I get t equals 2 seconds and t equals 8 seconds. I will assume you know how to solve a quadratic. And since I already figured out that v of t is equal to 160 minus 32t, I can plug in v of 2, v of 2, and v of 8. And what I get in both cases, I get 96 feet per second here. I get negative 96 feet per second here. And interestingly enough, or perhaps not, speed is equal to 96 feet per second in both cases, since speed is independent of direction.